Good afternoon, everyone. So today I'll be going through a short rundown on the subject of social network analysis. I'll be giving an introduction, applications, and some results. So, sorry. Okay. So we'll have a brief introduction of social network analysis, the methodology, as in how social networks are actually abstractified for analysis. We'll be going through some interesting applications and use cases of this method, and also some results, some very interesting results that are born out of this domain. Okay, swiftly moving on. Social network analysis is the process of investigating social structures through the use of networks and graph theory. The aim of social network analysis is to understand a community by mapping the relationships that connect them as a network and then trying to draw out key or the most influential individuals, groups within the network, cliques, and or associations between the individuals themselves. Now, the methodology. How we in graph theory, a graph theoretical definition is used to abstractify and realize a social network for analysis. The vertices, or in this example social network here, denote the social entities of the network, and the edges, which may represent a relationship based on whatever topological definition we want to utilize, and they also may have direction or weight. For example, an undirected graph would be a Facebook friends model, where if you are a friend with another person, the other person is also inevitably a friend of you. Directed graph example would be on Instagram, where if you following a person does not necessarily entail that the other person is following you back. And it may also have some weight, saying if you are in a friendship, you may either choose to classify using a nominal data type that they are best friends or they are okay friends, or you may also have some fuzzy number between 0 to 1 representing the strength of your relationship. Now, uh, actual social network graphs are rarely such simple graphs as the one I've shown on the left, but are rather quite complicated as so. For example, this is the co-authorship network map of physicians publishing on hepatitis C. So this is essentially a social network based on co-authorship on research papers that are published on hepatitis C. And I'm not sure if the DPI is visible even on the presenter screen, but that is a huge graph and calls for various technologies to, put out insight from such a graph. Now, let's go move on to some interesting use cases and applications of graph theory. First one being simple enough is supply chain management. A supply chain can be modeled into a network for supplier-consumer relations. Here, nodes include retailers, suppliers, warehouses, transporters, regulatory agencies, and so on. Network analysis on the supply chain helps us improve the operational efficiency by identifying and eliminating less important nodes, recognizing crucial nodes in the network, and create a standby in crises or emergencies, finding potential sources to increase the number of connections to your suppliers, or even by identifying bottlenecks that may exist in the chain. The second application is human resources. Human resource management often strives to identify critical resources and understand the contribution to the organizational flow, collaboration, participation, and also information flow. By using social network analysis, an organization can optimize the talent connections, productivity, and utilization. It will also help identify the reach of an individual, identify accelerators of growth, and poorly connected resources, and decide whom to give more opportunity. The third one, recent use case, was in COVID-19, was to monitor the transmission of infectious diseases. Social network analysis could help identify and isolate individuals or groups with high betweenness and out degree centrality. Now, these are all graph theory terms. Out degree centrality is the magnitude of edges going out of a node. Some graph theory uh, fabrics, transmitters of disease is essentially. We have abstracted those into nodes, right? And implement sound contact tracing activities to mellow the impact. Now, one very useful SNA application is in to counter terrorism. Now, John Arquilla and David Ronfeld's works on the title Networks and Net Wars describes modern terrorism as net wars. A net war being a lower intensity battle by terrorists, criminals, and extremists with a networked organizational structure. These network structures are often leaderless and are therefore able to attack more quickly. Novel asymmetric approaches are the only way to combat such a network based criminal organization. Terrorist organizations are well suited to study using social network analysis, as they consist of networks of individuals that span countries, continents, and even economic status and form around a specific ideology. Terrorist organizations are different from hierarchical state sponsored appointments in characteristics such as leadership and organizational structure. Social network analysis can provide important information on the unique characteristics of a terrorist organizations, ranging from issues of network recruitment, network evolution, and the diffusion of radical ideas. Finally, some very interesting results from this domain. In the first result, 6 degrees of separation, in 1967, Stanley Milgram conducted a test to understand how people are connected to others by asking random people to forward a package to any of their acquaintances who they thought might be able to reach a specific target individual. So there is some target individual that has been predetermined, anyone in this world, and this person has gone out to random people and asked them to forward the package to some acquaintance whom they thought would be more likely to be in much more closer proximity in terms of social proximity to this specific target. In his research, Milgram found that most people were connected by at most six acquaintances. This research led to the famous phrase 6 degrees of separation. There's a play, there's a movie, some 1993 movie, if I remember, and which at the end asserts that any two people in the world are connected to each other by at most six different people. And there's a famous quote saying, I am connected to the president of the United States or anyone between the six people. And the problem underlies in finding the correct six people. So that this is one profound result in my opinion. And the other one, a very concerning one actually, is the friendship paradox. Scott Elfeld in 1991 was the first to observe that most people have fewer friends than their friends have on average. Think about that for a moment. It is a very paradoxical statement in itself, which is why it's called a friendship paradox. Let me reiterate that most people have fewer friends than their own friends have on average. How can this be explained? It can be explained as a form of sampling bias in which people with more friends are more likely to be in one's own friend group. Now, if I am a friend with someone, it probably means that friend has a lot of friends. If my friend has a very low number of friends, that means it makes me being his friend a very improbable scenario. Contradictory to this, most people believe that they have more friends than their friends have. The same observation can be made applied to other forms of relationships too. As I was mentioning as an example, social media metrics such as following counts or friend counts is also a very valid relationship to be used in social network analysis. And this friendship paradox applies to every possible every possible topology that we use, which makes it a valid social network analysis. Because this phenomenon can be rigorously explained using the AMGM and Cauchy-Schwarz inequalities. So, why is this concerning? Because every social media user, no matter of our subjective following counts, they on according to their own context will feel undervalued. They will find that most of their friends on average are much more happier, they are much more wealthier, and for example, they have much more followings. Such an environment is what current social media is actually providing to the people, and such a phenomenon is surprisingly found as a result in social network analysis through a very simple proof, actually. If you are interested, I would suggest you to look it up. It's on Wikipedia, I think. And yeah, this brings me to the end of a very short run through social network analysis. Any questions so far?
Any questions?
Yeah, if you can ask me directly, that would be. I don't think I can't see the messages.
Okay, Vivek, thanks for the talk. I guess we have to move to the next talk. Okay,
Right, sir. Thank
so
you so much for this
yeah.
opportunity. I appreciate it.